Hey there, everyone. Nice to see you. This is, oh, we're doing it wrong. This is episode 33 of Project 2 of the Joy of Functional Game Dev. The GitHub release is v0.32.1, which is the start of episode 33. I had to do some monkeying around because I work on two different machines. One has Visual Studio 2012 and one has 2015. I wanted to do some cool stuff with test code and starting to mock things out and some interesting stuff. And I had some of the work done, and I'm like, well, I really ought to do that on the camera. So here we go. We're going to use. I was at a .NET user group earlier, well, last week, and he demonstrated using XUnit. And so what we're going to do today is we're going to bring in XUnit, not installed, all of them. So we're going to have XUnit on, actually we're going to need what we want. Let's have a test project. I'm going to make a new project, and it is a Visual F# library. Project 2.test. And if you've never written unit tests before, some of this may seem strange to you. Why are we writing code to test the code? And if you have written unit tests before, like, well, we're a little late. Why'd you write the tests after you wrote the code? Because test-driven development is, so I'm told, the way to go. So project 2.test will be the library, and I will yank all of this stuff out of here. Don't need those. One thing to note that I do have in here is I've got this thing called GameHost. The game is now runs in GameHost, and Project 2 doesn't have a main anymore. Project 2 has a game.fs, which has a run game function, which if you look at it, you'll see you will see the very familiar former contents of the main function. But so this is a what this does is it gives us a class library to test, and then a single the game host here allows us to just take that class library and run it. And so cool. All right. And additionally, we can start doing some other stuff like, well, there's all kinds of fun and interesting things we can do, and we're going to do them. So let's go here. We're going to manage some NuGet packages, and I want XUnit, and let's bring that in. I don't know that I need it on all of that. I think I just need it on the test project. Is that right? And naturally the latest stable. So let's do that there. So let's do that installation. So it wants all of that stuff. Okie doke. And it's going to do whatever its magic is. And we also want the Visual Studio runner. And I want that on here, I think. I'm going to install that as well. And okie doke. Now, let us write a test. And the test that I want to write, well, first I'm going to need to add a reference to project 2 and likely SDL2FS. I likely have to also add that one. I don't need. I have this little SDL2FS tester I haven't shown you. It allows you to actually. It's for building the SDL. Can't think of words today. It's for the wrapper, or for SDL, the SDL binding, in F#, and so it's actually does the things. But so it's a tester, but not in the same way that we're unit testing here today. So let's bring that in. So we got those, and we're gonna take a look at our configuration manager. We want you to be an x64 platform. Section solution platform are the same. Okay. What I just what new? Okay. All right. So we're gonna clean it, and we're gonna build it. So all right. So what's a good thing to start testing? And you'll see in some of the stuff. I'll show you all this in a minute. Exclude from code coverage. One of the things that is useful to do is to go, hey, these bits of code don't need to be counted. It'll just give you, hey, this was not covered by unit tests. And at least for now, because here's my record type. It's a cell location. But when we look at it later, and I'll actually take this out for now. We'll take a look in a second. And we're gonna do a some locations wrapped, because the rest of these are kind of private. So some locations wrapped. So here in Project 2 test, we're going to add a new item, and it's a source file, and it is some locations wrapped tests. I'm going to open XUnit. Is that right? XUnit exists. Okay, namespace XUnit. And what we're going to do is we're going to say, not you, okay, save everything here. Don't need you, don't need you. So the thing that I can do here is I need a world size of first and a second. So I'm going to let, and it's customary to kind of put these things in a one of these. And unfortunately, we don't have fixed values here. So we're going to say let world size equal column equal 100 cell and row equal 110 cell, just to give it a different height and a different width, because sometimes you mess when at least when I do stuff with X and Y, I will get different. I will get the wrong thing. I will switch X and Y all the time, so I try to put different heights. So the first position is going to be 1020. The second position will be 3040. And let the expected result full. And that would be 40 and 60. Let's get all these nice things lined up beautifully. Do that over there. Do that over there. So now we got all that. And we'll let actual equal some locations wrapped. So cell location dot some locations wrapped world size first second. I'm going to assert equal not empty. And this takes these things. Actual data. So, all right, that takes the tuple. So we say the expected, and then the actual. So, what should happen here? I do need to open cell column or cell location. So I don't really need to do that. And then one of the things we have to decorate this with is that this is a fact. And we're going to test Windows. Show me the test explorer. And we see some tests that I had that failed before. We're going to clean the solution. We're going to build it. We're going to have, hopefully, and hey, there it is. Look, 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 look. And it's here's the thing. See, some locations wrapped in bounds. Bounds no wrapping. So both locations with positive X and Y and no wrapping. So it's like some of the locations have both locations have positive and no, it doesn't wrap around. So I'm going to run them all. And we shall see, yes, that works. And for our next trick, see, but one of the things that's going to be, we're going to have very quick. So now we're going to make another one where I want it to so first location wrap in on negative x-axis. So I want to have the same sort of thing. Starts with 10, and I want this to be a minus. So minus 30, which will bring it, so make it a minus 20, and so then this should be an 80. And well, while we're at that, wrap on positive. Positive x-axis. And I haven't used this double tick mark thing up until now. If you haven't used the double tick mark thing, it's a way to name it whatever you want. Just put it in double tick marks, and this whole thing is the identifier. However, it means when you're like me and you like to double click on things, you're not going to just get the word. You're going, so, um, have put that in your pipe and smoke it. All right, so if I'm at 10 and I'm at 100, if I do a 90, then I should wind up with a 0 cell, right? Because it should never get to 100. And let's do this. Let's put this back at 30, 40. So let's do that one. So let's see, on negative y-axis, on again positive y-axis. So negative y-axis, I'm at a 20, so that's minus 40. So 110 minus 20 should leave me with a 90. And that's 110. So the only thing that's something that would make it a, so if I put a 90 here, that one should be a 0. And there we go. And let's run them all. So as we can see, everything runs. But now the more important thing here is I'm going to take a look at the code coverage. And the code coverage is so we covered a total of 26 blocks. And what is a block? And that's a fine question. So here we are in cell location. Where are we? So in cell location, we've got some locations. We've got some locations wrapped. Okay, this is now way more useful. Some locations wrapped. It's kind of this light blue color. And we now know first, second, and wrap the location. Now, the thing here is that I do have some guards that I wrote in before for 0 or less than 0, because world size of 0 or less doesn't make any sense. So ultimately here doesn't really much matter. So we're going to take this test. So we're going to say with 0 world width. We're just gonna do that. And might as well do it with 0 world height. We'll put this one back. Okay. We'll put the negatives in there with negative. So minus 100. And negative world height. So that was minus 110. And now, having not changed these in the slightest, writing the tests after the fact, we run them all, and we will see very quickly that these are no good. because they explode with a exception of type. I have a special one here. It raises invalid world size. So invalid world size. So this is dead of that. I don't need an actual here. A 0 world height. So we're going to we still need that. So we're going to assert rows. The name of it is invalid world size. World size, and this has to be an action, which I have to look this up right quick because where's it? Fun. Do this thing. Does that work? Okay. Okay, what is your problem? No, over. So, what is it? See, I don't know how to do it, but what I can do is let do test equal. Wait. I can do this because it does actually return something. Ignore. Okay. So, yeah. Sadly, we kind of have to, kind of weird. That's the way of things. So then actually all 4 of these should now pass. That's very cool. And now we're going to analyze code coverage for it. We're going to see we've gone up a little. And we've got cell location. No, not that one. Just under cell location. We got wrap location. See, in this right here, this is the thing that bothers me the most, is I'm reaching this line. It's true. And it's throwing, so I have covered it. So it's a bizarre thing. And also, invalid world side, get hash code. I don't care to test it. And then also cell location, this has a compare to. So these and the get hash code, and there's stuff that's magically there that just when I type it, and that's where exclude from code coverage. We don't need ya. Same thing on you, Mr. Invalid World Size. There's another one here that we'll get to in a little bit. So yeah, now let's get a little better count. Okay, cool. See, and now it is telling me that these things are not getting invoked. And that's why in assembly info, that is why we're going to say assembly with 2 S's, putting the S in assembly. System.diagnostics.code analysis.exclude from code coverage attribute. Can I do it to the assembly? Can't do it on the assembly. Very well. Kill that. And put it on this here module and all modules. Just to say, you know what? I don't need you looking at this. Is there a better way to do it? Probably. However, I'm not terribly concerned at this time. So let's, here in the project, we want, so the things that we've got, wrap location just has the 1. Nothing we can do about it, raises that. So the thing that I still have to cover is the distance formula test wrapped. And then we'll be done with the cell location portion of the project. Okay, so let's adding a new item, source file. So what do we call it? What is it called? Distance formula test wrapped. So add a new reference, or add a new item. Change it to an E. Tests. Okie doke. We want to kind of do the same thing going on here. So we need a world size, we need a maximum. And we need a first and a second. So it is rather similar to to this. Of course, we can very easily. So let's take that. Don't need you. Don't need you. What we do need, though, is we need this. Put this over here. So, just for reference, we're going to let you know, 0 world width. Now these will be facts. We'll assert. I've got to open X unit. Assert dot fail. Is there one that just like explodes? For now, we'll just put assert true false, which will always explode. So this will fail because this is my, actually just raise not implemented exception. Open unit, open system. Raise new not implemented exception. Whatever. All right. So we need the 0 world width, 0 world height. And then we need negative world width, negative world height. Negative world height. And I believe also once it gets into the distance formula, you cannot have a negative, a less than 0 maximum. So there's that negative maximum. And so then we begin. And we need a let world size equal column equal, this is the one that's 0, row equals 110 cell. Let maximum equals 0 cell, because it doesn't matter at this point. Let first equal, and this also needs to bring in open cell location. And second also needs to be that. Second. And we are going to assert rows. The first thing that it does an invalid world size. Invalid world size fun. Distance formula test wrapped world size maximum first, second, and ignore. Did you work? Do you work? You work. Great. We'll take that. We'll put that there. This one will be 100. And this one will be 0. Do the negative width. Negative 100. We'll take the negative height. Negative 110. Then the negative maximum as well, which means we get past the first one, and we get just put a -1 on there. And that one should be a different, that one's just negative value. Okay. And now, hopefully we see all of these running and passing. And yay! And now let's take a look at the code coverage. And you'll see very quickly the heartbreak, which is, ooh, I'm at 90. I've so far gotten the whole, well, at this point, a little over 3%. And I've only got 10 more in the block. So what's not covered here? So at the moment, I have the check for that. So I need to see that the maximum is greater than that, and then it's going to call into that. Because what else here? But we're gonna wrap them up very quickly. All right. So for my next trick, let's have a we're gonna with a 0 maximum, 0 distance. So this where are they? Oh, what am I doing here? So all these things, these don't need to have any values. Fix it. Da-da-da, 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 da-da-da. So there should be let expected equals false. I think I expect a false. Okay, so let actual equal distance formula test wrapped world size maximum first second assert equal not empty equal expected actual. So was it true? I'm not sure. Well, I do know that the so one distance. So we're going to put 0, 1 second. Okay. And we'll go with the true. Either we're totally wrong or we're totally right. If I have two looks like I pass. And analyzing the code coverage for all the tests. And we've inched up just ever so slightly. Cell location. What's left? Okay. So we're down out of 3. This one has a place where I'm raising the exception. This one where I'm raising an exception. So I'm down to my exception raises, which means I'm down to the 3, and that's the best I can get. So somewhere around 95% code coverage is the best I can get, because there's certain parts that just won't cover. And maybe I will figure out one day how to make that work, but today is not that day, that's for sure. And so then let's take a look at so okay, that's one where that's very mathematical, very yep, you can test to make sure that these mathematical functions perform right. And so it's like, okay, cool, that's useful. It's useful in that, okay, if I then later go in and change them, these unit tests will fail. And so the very first thing that'll happen is the unit test will tell me, hey, you broke it. But now let's take a look at something else like event pump. Event pump, which currently is not covered in the slightest. But the thing is actually as a result of some of the refactor, I've got an event poller, an idle handler, and some other things. And I've also got t-state. Now t-state can be anything. T-state could be an int, for example. So let's check out. Let's do an event pumps test. Add new item. So event pump tests. So we're going to open xunit, open event pump. We're gonna grab out these things. How about that? And I also think I need to open SDL event. I think I do. Then, do I still have the thing at the top? I do. Let's yank it. Don't need it anymore. So event pumps tests. here is the event pump. Grab the function signature for it, plop it on down, select event pump, and perhaps the only way out is for the event handler to give me a none for my new state. So I need an event poller, and that's one of these. Event pump. Poll event state handles poll event handle to none. Okay. Let event poller. Now the event poller, which returns one of these, equals SDL event dot other. Okay. Other 0u. Do it this way. 0u. Give me one of those. Give me a sum. Oh, sum. Gives an event. Okay, so that's the event option. Let event handler. So let me have the idle handler. Idle handler state equals do some nothing. Let event handler event and state equals this needs to return a none. And then I need my state. State equals 0. So, okay. So, event pump, event poller, idle handler, event handler, and state. And then this one is very race. So, I'm going to make that a fact. And run them all. Because it should actually work. Okay, cool. Where's my event pump? There it is. But now, it goes through, and I know that things happen, but what I don't have is anything to verify. So perhaps I can have a let events polled equal ref 0. I don't know that I can events polled equal events polled +1. I don't think I can actually do that in here. Yeah. Doesn't like it. So I'm going to pass something. So events, call it a counter, which is a ref int. we're going to say counter colon equals counter plus 1. So we're going to do a similar thing here. And this is, if you haven't seen this construct before, we all know mutable type's bad, right? But by the same token, we need to do some things. We need to count things. We need to have some mutability. And right here, it's like, okay, you know, what'd be really useful for me is if I could, more or less, increment a counter every time I did this. This is called let events handled. Okay, now these things are wrong because they need to be curried. Okay, now event polar, events polled. Idle handler idles, event handler events handled. Now, call my expected, I have no idea what I expect. And then events polled. Get out. 2, 3. Events polled, idles, events handled. So now my function should fail, and I don't need this anymore. I think I probably need a couple more of these functions to completely get through. So now it fails. Put a breakpoint here, and we're going to debug the test. Okay, so the events polled is 1, idles is 0, and events handled is 1. So it should be 1, 0, 1. And that is, I believe it to be completely accurate. 1, 0, 1. So run the test. And now it works. Poll event. Okay. Well, let's take a look. Let us take a look at the code coverage of the event pump. And now this whole thing reflects nothing. So, yeah, this is the this is telling me that SDL, that it wants my SDL assembly, all this stuff covered, whereas I really don't care about it. I care about these. So I'm at 96. So almost got 4. Almost got 4. And so, okay, so we're in my event pump. Event pump says, okay, we can start to see it's like, okay, well, I pulled an event and I got a sum. I didn't get a none, so I haven't gone to here. And what I've done is I've matched the event handler, but only matched the one where I've gone to none. So we're in a flux here. And so let's make another one. So let's do one where, do I need a stale event? I don't think I need it. Where should I put other sum? All right. Okay. Take more or less the same function. Copy pasta. Event, pull event. No event. Idle. Pull event. Handle to none. So, what I want to do is the first time I pull, I want nothing. So, if counter equal 1, then else none. All right. And we're going to run it all. Oh, that one doesn't work. So, let's see what the problem is. Because obviously we have different counts on how many times the events were pulled. We've got 2. 2 times that function is called. Idled once, events handled once. So 2, 1, 1. 2, 1, 1. Run it. And now it passes. So, event, pull, event, handle to some, pull event, handle to none. So, every single time I'm going to get an event here that does nothing. And here, when I'm handling the event the first time, I want to if counter equal 1, then else. So the first time, I want to return state sum. Don't even really care what the state is. Could be unit. Doesn't matter. Now I run all. And that one's broken. Let's find out what your counts are. So, I don't care about that. Continue. So here's events pulled. 0. What? What? Need the counter goes. What happened? Handle to sum, full event, handle to none. Must have done something strange. So debug it again. So the event pulled is 2. Idles is 0. Event handled 2. And while this is, so some things are trickier to unit test than others, so now it should pass. And then just to check, we will take a look at our code coverage on event pump. The only thing we care about is the event pump, where we got 100% covered. Look at you. Look at all that. Not that there's a whole lot of code here to handle, but that is a good thing. And so we also know because after this, before when this is calling SDL get the event, and now that's getting passed in here. This allows us to do mocking. And there's another little aspect to mocking that I want to at least get in here, and especially for unit testing, because we have a game here, and so I'll just look for random in FS match the whole word. How many places do we use random? So you see, so what I want to be able to do, because most of the time, so I need, there are some where it's random.next, there are some when it's that random.next, and some, I think that's about it. So it's random.next and just random, and then sometimes on a maximum. I don't think there's any place where I'm using a double. And this is going to be kind of invasive, but what I really, really need to do is I need a random func. I'm going to add it here, and we'll just see how far we get with it. So we're going to go random. And really this is just to allow me to maximize things. Or is this just utility? We'll just call it random. Call it utility. I already have utility. Typically I wind up with something called utility for too long. My contents. Just not. I'm gonna call it random. Add new item random. Okay. So random. Let random parameter equal this is the next max range of int times int. I'm doing a discriminated union. Am I not doing it right? Type is what I'm doing wrong. So my random result called next int range. Oh, is there any place? I don't think there's any place where I actually need a. I might as well do it. Next float. That's all I really need, isn't it? And type random result equals int float of float. So sure. So type random func takes a random parameter, returns a random result. Okay. And then so here's random func, and that's all I really care about, isn't it? All right. Sure. And I'm going to throw this into game. Well, no, this has got to go. Not sure where exactly this will get needed. Okay, I know at the moment, definitely needed for game. Well, what's this stuff here? So I got event handler and map cells. So right there. So game is going to take a random func, which is a random func. And random. And what we're going to do here is this is going to be let random func random open random func. It's going to be parameter random parameter random result equals build some stuff. Okay, and things are okay. So that's good. Match parameter on with, and my random parameter, there's a next int. So random func random, which is a system.random. So next int is just going to be random.next, and my result is a next is a int. Okay. The next one is a max int. Int max, give a random next max. That's also an int. There's an int range. Min max. Random.next. Min max. Int. Next float. random dot next double. And that's a float. So super cool. So let random equal new system dot random. Then func random. So then way out here is where my random will get injected into the game. I'm going to need a couple of other let get int result random result int equals exception valid wrong random result type. So we're going to match result with int value, otherwise raise wrong random result type. Explode, get float. Float value float. And that's cool. So now I can do random get int, random get float. Okay. And now we've brought it into here. And what we need to do is we need to find where's all of this stuff. So where are the places it gets put into the create func, the create world, and the event handler. And both of which has a great deal of work. So we've got a long way to go with this refactor. But just before we go, well, let's get these things excluded. So we're going to open that stuff. Open that. And these things can be excluded because they're types, and so we don't need them covered at all. I don't even know if that one needs it or whatever. We'll put these down here. These we do need to test. So let's do it while we're doing this. So add a new item. We're going to have random tests. open random let random result int passed to get int. Call let. So we'll just get. So we're gonna have a float passed to get int. Int passed to get float. Int passed to get float. Calls. So it's random dot get int. Okay. Build it, and then actually let's just use the thing. Okay. So let initial equal 0 random dot int. Initial is that, and then what also gets used there? 0.0 random dot float. And then let expected equal 0. Let actual equal initial random dot get int assert equal. So open x unit. Make this one a fact. So equal expected actual. And then let's more or less the same thing here. 0.0 float. Get float. Expected is 0.0. I'm missing a one of those. There's that one. So the float passed to get int. So it is 0 and random int. We don't. While we have an expected, so we need to do a assert throws on something that is in there. Doesn't work because it should, in order to compile, it should have an ignore. And the type is wrong random result type. We'll put a random in front of that. Okay. Get int here. we've done some testing. Cool. Now, should have kind of done that before we wrote our code, but that's okay. So run them all, run them. Hey, look at that. So, random tests. Now let's take a look at our code coverage so we can take a look at the random stuff. The random stuff should all be of course, and that needs, okay. I don't mean to be whiny, but this is kind of annoying. There are a lot worse things to complain about in life. So I got a random. Ooh, lots of things in there. Random. So I have the parts where I'm raising things. Other than that, we're covered for code. And we're going to call it for the day. So today we started on getting rid of system.random in a way where we can now inject things into our, we will be able to inject our own custom random func in order to test out how it looks. So, thanks so much for coming on this journey with me. And it does not look like Project 2 will be wrapping up anytime soon. But as always, keep that joy of functional game dev in your heart, and I'll see you next time.